Morning, everybody. This is your geography assignment number 5, and this has been issued on Monday, the 15th of June. To complete it, you need to use the Hydrosphere number 5 document that you'll find with this assignment, and obviously you need to be watching this video. This document, all of the videos that go with this document, you can find in the main assignment document, which you can see is titled Hydrosphere assignment number 5. So make sure you have that open, and you'll see that there are 4 video links which will each help you answer the 4 questions that go with this particular assignment. Okay, and you can't really answer these questions unless you watch these 4 videos. But before we get to that, I'd like to just introduce what we are looking at. So far, what you've done in geography is you've thought about river landscape features and how they're formed by a river. And in the last assignment, number 4, you were also beginning to think about how the landscape itself, in the case of the types of things growing on that landscape, the soils, the rocks, the slope of the land, and all those other features that surround a river might influence the way water moves across the land. And your first task, as you'll see in this first tutorial, is going to deal with, in this case, human factors that can influence the discharge of a river. Okay, so what we're dealing with here is this idea that the discharge of a river is the amount of water in a river, and that when it rains, the river's going to go up. Okay, that's nothing surprising, and that's what we would expect. And hopefully that's very clear in your mind that heavy rainfall, you'd expect a river to go up. A long period of drought and no rain, you'd expect rivers to be quite low. But the key idea that we're thinking about is that actually the landscape that surrounds a river, what's known as its drainage basin, and that's the area that the river drains, can have various characteristics that can influence what happens when it rains. Does the landscape absorb a huge amount of that water? Or doesn't it? Does the water move across that landscape really quickly to the river, or does it move quite slowly? And these different characteristics of the surrounding drainage basin will influence how quickly a river rises and falls. And that idea is explored here in even more detail when you'll be learning that it's not just natural things in nature that influence how water moves across the land, but actually we humans have a huge role to play in that as well. So you'll complete that task first. But then the main part of this, and where all this understanding is leading to, is the second task. And in the second task, you'll first of all be introduced to this thing called a hydrograph. And there is a tutorial, and I'm just going to show you this one here, that will explain how to understand what this graph is all about. And it will help you answer these 6 questions, identify what these 6 things are. And then actually that then leads you to what I think is the first key learning outcome for this part of the topic. And it's really important that you, if you're watching the video right now and you've got to this point, that you pay close attention. Okay, this is a graph of a river. It's a graph of a river's discharge changing when it rains. Okay, so what I want you to do is, I know it just looks like a line graph and a bar graph, but I want you to visualize that these bars represent it raining. So for the first hour of the day, there's no rain. And then after the first hour, it starts to rain lightly, then 5 millimeters. We can see that on the scale. Then it goes to 10, and then it goes to 20. And then between the fourth and the fifth hour, it drops back down to 5. Okay, so there are 4 hours of rain, and between the third and the fourth hour, the most rain falls, in this case, 20 millimeters. The red line represents a river that happens to be flowing across the landscape where that rain is falling. So this is the rain that falls on the drainage basin, and this line represents what the river does. Now, because it rains, the river starts to rise. What you'll notice is in the first hour of rain, the river doesn't actually really rise at all. And that's actually because it takes time for water to actually get to a river. Only a tiny amount of rainwater actually falls in rivers. The rest falls onto the surrounding landscape and has to start to move because of gravity towards that river. Okay, so it does take time before the river reacts. And what this line shows is the river's discharge. And remember, the discharge is the amount of water flowing past a certain point in the river every second starts to rise. And we can see that in the 7th hour, that river peaks. It is at its highest up here. And if we just track across on our graph, we can see that's 110 cumex. So cumex is cubic meters per second of water. passing a point in the river. Okay, and that happens at the 7th hour. And after that, the river discharge starts to fall. I always think the best way to think of discharge is just think physically the river's getting higher and then it's going down. Okay, now that's what I need you to visualize. It rains, a river rises, and then it falls. What's interesting though is the river stops, it stops raining after 5 hours, but the river keeps rising. Now that's because the landscape's like a giant sponge. It soaks up huge amounts of water, and then over time that water continues to dribble out into the river, even long after it's stopped raining. It's actually why rivers still have water in them after a month of no rain, because water is still coming out of the landscape, which has been soaked up by the landscape and is gradually just feeding the river. Now, I'm going to show you the main bit of today's lesson, which at first appearance looks kind of really dull, but it really helps you visualize what's happening. And in this YouTube video that I've got on silent, we can see a landscape. And in front of you here, you can see a dry riverbed. Now, it just happens to be a drainage ditch dug by somebody next to a road. So we can see a road over here. We can see a gentle slope on the right-hand side of our river with forestry in the background. Okay, so what do we expect? Well, it's going to start raining. We can see the rain clouds coming in, and only a tiny amount's actually going to fall in here, so little that there will not be a river. But the water landing on this road is going to drain very quickly because of a little culvert here, which is connected to a drain in the road. So the water on that road will start to collect, go down this little drain, and will start to fill up our river. Then water will start to come across the surface of this slope and feed the river as well. And then water coming through the soil will then arrive. Now, that'll take a little bit of time. And then water that's landed on this forest will drip down and move through the soil and arrive in this river as well. Okay, so I'm now going to play the video, and you're going to see it's sped up 50 times. Okay, and now it's starting to heavily rain. Okay, so the rain's falling. And down here, you're going to see a graph appear in a second. And this is our hydrograph. And I'll just talk you through what you're seeing. So here comes the first water. And this is the water that's fallen near the river on this road. And it's draining off the road into the river. So our river's starting to fill up and it's rising. You can see down here, it's actually rising. Okay, so this is the discharge rising. Now this graph shows you, as this dot goes up, it shows you this level of river rising. Okay, now you can see this first little dash has been put on. This was the peak rainfall. So when it started raining, they recorded the time when the rain got to its heaviest. Okay, and now we're beyond that point, but the river's still rising. And that's because water's now, you can see it coming from the hillside over here. It's pouring off. It's what we call surface runoff. It's still coming from the road. And therefore our river is continuing to rise. So let's just watch it rise even further. You can see it's still going up. Okay. Now, we are now almost at our peak discharge. There we go. So that first line represented the peak rainfall. That was when it was raining at its heaviest. This second marker on this little line represents when the graph actually got to peak discharge. So that's where this river has got the most water in it flowing past. Okay. But instead of just dropping straight back down, it now takes time to fall. This rising bit of the graph we've actually got a name for it. It's called the rising limb. It's where the discharge is going up. And this bit's called the recession limb. It's where the discharge goes down. So let's just play that on. So now if you watch closely, you'll see the river started to go down. Now, it stopped raining. It actually stopped raining quite a while ago now. There's no rain falling, but water is still filtering in across the surface a little bit. A lot is coming in through the soil. And actually, over time, some is going to feed in from rock underneath this soil. So the water in this drainage ditch will actually take days before there's no water in it again, because water will continue to trickle through the soil and through the rocks and feed through from the forestry up here into this little river. Okay. The key moment though was this. We were interested in how quickly did our river rise and how quickly did our river fall. Okay, now I'm just going to pause it here. This is called a hydrograph. It charts the speed at which a river rises, and we can see that was really vertical up, so it was a quick rising river. It charts how high the river goes, that's the peak discharge, and then it tracks how quickly the river falls. And what influenced this rise and fall was the road. Water that landed on the road was the first water to arrive in this river. Then water coming off the slope here arrived. Then water that was coming through the soil, it started to feed into the river. We didn't even see it. It was just feeding the river. And then water that had fallen way back here on this forest and far over here on this part of the landscape will have gradually filtered through into this river. And actually, if we went on for another couple of days worth of time, it would take a long time to get right back down to this bottom level, which is when it was empty. Okay, so I'm just going to come out of that. Because that was a visualization of what this graph is showing. Here's the rainfall event. This was the peak rainfall. Here's the peak discharge. Here's the steep rising limb. And here's the falling limb. Once you've answered this question, you've got one final large exam question, and I've got a tutorial here, and this is the last one, that will help you answer this question. I give you the descriptive starters for this question, and I do that in the tutorial, and I also outline what you're going to be looking to explain. So this is a describe it and explain how that affects the surrounding drainage basin, and I've got a tutorial that helps you answer that. Okay, so please watch all of the tutorials that go with these 4 questions. They'll make answering each of these questions really easy. And then your assignment number 6, which is your last assignment for the whole topic, is just going to be you trying to answer some actual exam questions that are very similar to this.